Ever played games like WipEout or F-Zero and thought, that's just crazy sci-fi fun? Well, what if I told you that the high-speed, gravity-defying tracks from those games might not just be fiction? What if they're actually a blueprint for how we'll build transportation networks in our future space colonies? It sounds wild, but when you break down the engineering needed for a permanent base on the Moon or Mars, you start to realize that the most practical, efficient, and safest solution looks uncannily like something straight out of a futuristic racing game. The core ideas from WipEout, levitating vehicles, magnetic tracks, and mind-bending speeds aren't just cool concepts. They're solving real-world problems for off-world living. Let's start with the basics. The vehicles in these games don't have wheels. They float. This is magnetic levitation, or maglev, and it's key. On Earth, maglev trains are already a reality, using powerful magnets to lift the train off the track, eliminating friction. In a space colony, this is a game changer. Imagine the Moon, covered in fine, abrasive, and electrostatically charged dust. It's a nightmare for any mechanical part. Wheels would churn it up, kicking it into the air where it can damage seals, clog mechanisms, and even pose a health risk if it gets inside a habitat. With a maglev system, a rover would just float silently a few millimeters above the surface. No wheels, no grinding parts, no dust clouds. It massively reduces wear and tear, which is absolutely critical when the nearest repair shop is millions of miles away on another planet. Maintenance is one of the biggest challenges for any long-term space mission, and maglev elegantly solves a huge part of that problem. But levitation is just the beginning. How do these vehicles move? In WipEout, the track itself seems to push the ships along. This is the second piece of the puzzle: linear motor propulsion. Instead of the vehicle having a complex engine to generate thrust, the roadway itself becomes the engine. Imagine a track made of special panels. These panels contain coils of wire that can be precisely controlled to create a moving magnetic wave. The rover, equipped with its own set of magnets, it's caught in this wave and is literally pulled or pushed along the track. A central computer could manage the entire network, controlling the speed, spacing, and routing of every single vehicle. This means no traffic jams, no collisions, and incredibly efficient, automated logistics for moving cargo and people around the colony. It's a perfect system for autonomous rovers running 24/7. Now, this is where it gets even more interesting. This magnetic roadway isn't just for moving things around. It's also a power grid. You've probably heard of wireless charging for your phone. Now, imagine that on a massive scale for a whole fleet of rovers. This technology is called dynamic wireless power transfer. Here's how it would work. The same coils in the roadway that create the magnetic wave for propulsion can also be used to transmit energy. As a rover moves over a powered section of the track, an oscillating magnetic field is generated. This field induces a current in a receiver coil on the underside of the rover, wirelessly charging its batteries as it drives. This completely eliminates range anxiety. A rover could theoretically operate forever without ever needing to stop and plug in. This means smaller, lighter batteries, which in turn means the rover can carry more scientific equipment or cargo. But the system is even smarter than that. It doesn't just give power, it can also take it back. This is called regenerative braking. When a rover needs to slow down or is going downhill, the process is reversed. The rover's motion and momentum, moving its magnets past the coils in the track, now generates an electric current in the track. This electricity can be fed back into the rover's own battery or sent directly into the colony's power grid. So, the very act of braking reclaims energy. It's an incredibly efficient closed-loop system where almost no energy is wasted. So, we have levitation, propulsion, and power all handled by the track itself. But what would this track actually look like? Forget pouring asphalt on Mars. That's messy, complicated, and not very durable. A much more brilliant solution is to build the roadway out of modular, interlocking hexagonal panels. Think about it. Hexagons are nature's perfect shape for tiling a surface without any gaps. They are strong and distribute stress evenly. These panels could be mass-produced, with all the complex magnetic coils and electronics embedded inside during manufacturing. On the Moon or Mars, a deployment rover could simply pick them up and lay them down like Lego bricks, clicking them together to form a road wherever one is needed. Need to expand the colony's road network? Just add more panels. Is a panel damaged by a micrometeorite? No problem. A maintenance bot can pop it out and slot in a new one in minutes. This modularity makes the entire infrastructure incredibly resilient, adaptable, and easy to repair, all essential qualities for a fledgling off-world settlement. And we can take the design one step further, leaning even more into that futuristic WipEout or even Stargate aesthetic. Imagine curved arms arching over the sides of the roadway. These aren't just for show. They would serve multiple critical functions. First, they could house additional magnetic coils. These would help generate the fields needed for not just levitation, but also for lateral guidance, creating invisible magnetic walls that keep the rover perfectly centered on the track, even at high speeds or in low gravity. No risk of sliding off the road. These arms could also help contain and focus the magnetic flux, making both propulsion and wireless charging even more efficient. Second, these structures are the perfect place to mount everything else the colony needs. In the harsh darkness of space, or during the long lunar night, they could be lined with high-efficiency LED lights, illuminating the path for cameras on autonomous rovers or for any human-driven vehicles. They could also act as protected conduits for power cables, communication lines, and maybe even pipes for life support gases or fluids, keeping all that vital infrastructure safe from the surface environment. So, when you put it all together, what do you have? You have a transportation network built from modular hexagonal panels. It uses magnetic fields to levitate vehicles, eliminating wear and tear. The track itself propels, guides, and wirelessly charges the rovers as they move. It even recaptures energy when they brake. The whole system is clean, silent, incredibly efficient, and perfectly suited for an automated, high-tech society on another world. It turns out that the visionaries behind games like WipEout and F-Zero weren't just creating a fantasy. They were accidentally predicting the most logical and elegant engineering solution for humanity's future in space. The next time you see those glowing, futuristic tracks in a video game, remember that you might just be looking at the highways of tomorrow, built not on Earth, but among the stars. Thanks so much for watching. If you found this journey into the future of space travel as exciting as I did, please hit that like button and consider subscribing for more deep dives into science and technology. Let me know in the comments what other sci-fi tech you think might become a reality. Until next time, keep looking up.